Let's see this question. Well, given a path means going from one space to three space. And I'll give another function going from a three space to three space. So we are asked to find the composition of F with the path C. And we can always draw this picture. If we draw R3 here, so this is a C, this is F. So F takes C, F composed with C means F going from one space to three space. Okay. Then afterwards, we need to find its tangent line at a given value t equals to 1. So let's find the composition of first. So F takes C composed with C, which means F takes C as input. So how is the C defined? That's T squared, T cubed. So with function F, that's X, that's Y, that's Z. So how is F defined? It's multiplied by the first xy, multiply x and y, so get a t cubed. The second component is x squared plus y squared. X squared is t squared plus y squared is t to the fourth power. Then z, right? Z is defined as t cubed. So that's it. That's F composed with the C. Then we need to find the tangent line at t equals 1. Remember, a line representation in higher dimension equals the initial vector. We use a vector, initial vector plus variable t minus 1, because at the time 1, then multiply by the direction vector. Direction vector. Right, so we need to find initial vector and direction vector in this case. So initial vector, we can treat the point at t equals 1, right? So we just do F composed with C, evaluate at 1. Well, 1 to any power will be 1. So T, 1 to cube is 1. 1 squared plus 1 raised by 4 is 2. And 1 to the third power is still 1. So this would be our initial vector. Oh, I shouldn't write. Let's just calculate. I shouldn't write this one here. So that's our initial vector. We can always treat this point as a vector starting from the origin to this point. Now, direction vector. How do we find a direction vector? Direction vector, we want to take a derivative of this, right? The derivative of this will be a velocity vector. So which means we take a derivative of the first component, we take a derivative of the second component, take a derivative of the third component. So when we do that, we get t to the third power, that's 3t squared. T squared to t. T to the fourth power derivative 4t cubed. Then derivative of t cubed is 3t squared. So when we evaluate at the value 1, so evaluate at 1, so that's F composed with C of 1 derivative, right? So the velocity vector at t equals 1 will be 3 times 1, 3, 2 times 1, 2, 4 times 1, 4, 2 plus 4, 6. Then 3 times 1 is 3. So this would be our direction vector. So direction vector. So now we can write our line, right? Tangent line representation. Initial vector plus t minus 1 times our velocity vector, which is 3, 6, 3. Or we can simplify this a little bit because L of t is a vector. So I have 1, 2, plus t minus 1 times 3, we've got a 3t minus 3, then 6t minus 6, Then again, 3t minus 3. So we can add those two vectors. 3t minus 3 plus 1, that's 3t minus 2. 16 minus 6 plus these 2, that's a 16 minus 4. 3t minus 3 plus 1, again, 3t minus 2. That's it. The tangent line representation as a vector, as this.